Notes over 10.5, we're covering secants, tangents, and chords. Now we've already talked about these different lines and segments, how they relate to circles, but now we're going to use them and show how they work together to create angle and arc measures and how to find the degrees of different angles. Okay, so first of all, a tangent. If you remember, a tangent is on the outside of a circle. It touches the circle once at a point of tangency. So this is a tangent. The point where it touches the circle is the point of tangency. Point of tangency. And then a secant goes through the circle and it touches it twice. All right. So those are the two things we're going to be working with. The first two theorems we're going to cover are in this box. The first one says, if a secant and a tangent intersect at a point on a circle, here is your secant, and here is your tangent. They intersect at a point on the circle. Then the measure of each angle formed is half the measure of its intercepted arc. So here's an angle that's been formed. It is half the measure of the arc that's been intercepted. So I'm going to trace arc AC so you can see what's been intercepted. To explain this, we're going to call this angle TCA. So the measure of angle TCA is equal to the measure of arc CA divided by 2. So if this angle was 35 degrees, then this arc would be 70. And just the opposite of that, if this arc was 70, then this angle would be 35 degrees. All right, now, in the next theorem, if two secants intersect inside the circle, we have these two secants and they are intersecting inside the circle. Now, this intersection does not have to be the center of the circle. They can intersect anywhere inside the circle. Then the measure of the angles formed is half the sum of the measures of the arcs intercepted by the angle and its vertical angle. Okay, in reading that, you might just be going, what is that saying? Let's focus on angles 1 and 3. These are vertical angles. And if you notice, the arcs that have been intercepted across from these angles are ST and RU. All right, so what we're saying is that angle 1 and angle 3, that their measures are equal to the sum of these two arcs. So the sum of arc ST plus the sum of arc RU divided in 2. So depending upon what the measures of these arcs are, we would add them together, divide by 2, and that's the degree of each one of these angles. Now, arcs SR and TU right here. Okay, they are formed by angles 4 and 2. So angles 2 and 4 are equal to the sum of arc SR plus arc UT divided by 2. And we're going to practice some of these problems on the back side. Now, or at the bottom of the page actually. So now then, the next theorem, this has 3 possible cases to it. If two secants, a secant and a tangent, or two tangents intersect in the exterior of a circle. We are now talking outside. This was inside. Now we're talking about the outside of a circle. Then the measure of the angle formed is half the difference of the intercepted arcs. Notice here we added the intercepted arcs and divided by 2. That's if we intersect in the inside. If we intersect in the outside, we subtract the arcs, that's what the difference is, and divide by 2. Now, the first scenario, if 2 secants, that's this one right here, number 1. 2 secants, AC and AT are both secants. Notice they intersect outside the circle out here. So the arcs that they intersect are CT and BR. All right, so we would show that the measure of angle A, this angle right here, is equal to the difference of whatever arc CT equals minus the measure of arc BR, and then we divide that in half. So if we knew the degree of these 2 arcs, we would subtract them, divide by 2, and we get the degree of angle A. Okay, a secant and a tangent, that's this scenario right here, a secant and a tangent. Okay, so we've got a secant, which is DF, and a tangent, which is DG. All right, they intercept arc FG and EG. We would subtract those 2 arcs and divide them in half to get the measure of angle D. So the measure of angle D is equal to the measure of arc EG, I'm sorry, that should be FG, FG minus the measure of arc EG. You do want to put FG first because that's going to be the larger arc, and you do not want a negative answer. You have to have a positive answer for that. All right, then the last scenario is if you have 2 tangents. This is scenario 3. 2 tangents. Well, here's tangent HK, and here's tangent HJ. Now notice what we've got here. We have cut this circle into 2 arcs. There's one major arc, and then there's one minor arc. We are going to subtract the minor arc from the major arc and divide it in 2. So the measure of angle H is equal to the difference of arc KXJ. Notice I gave it 3 points because it is a major arc. And we're going to subtract arc KJ. That's this way. That's your minor arc. And again, divide it by 2. All right, so down here at the bottom, we're going to practice these problems to solve for x. Now, if you look, these 2 lines are secants. They intersect inside the circle. So this is the formula that we're going to want to use. We're going to want to add the 2 arcs that are intersected and divide by 2. So in this case, I know arc UT and I know arc RS. So those are the 2 arcs I'm going to add together. So the measure of angle X is equal to, and actually I shouldn't call that angle X, I need to call that TXU. So we'll call that TXU, is equal to 85 plus 230 divided by 2. 230 plus 85 is 315. So half of 315 is 157.5. So that's the degree of that angle. As you can see, it's not really drawn to scale. Okay. The next one, we've got the measure of angle MON. Well, here is angle MON. Now, it equals half the measure of its intercepted arc. Well, here's the arc that's intercepted. We don't know the measure of it, but we know the measure of this one. And again, this is obviously not drawn to scale because this is showing that it's a minor arc from here to here. All right, I'm only doing this to make sure that you go through the formula process. All right, if we have the situation, it says to take the degree of the measure of the arc and divide it in half. So, if this is 102, then ON, arc ON, is equal to 360 minus 102. All right. Now, I actually kind of changed this on my set of notes just so it would make more sense. I think I want to go ahead and do that. Let's go ahead and do that. We're going to say that this is 258 and that this is 102 right here. Okay? All right, so ON is 360 minus 258, which is 102 degrees. All right, so if we cut that in half, we get the degree of angle MON. So that angle would be 51 degrees. All right, the last scenario. I'm looking at my notes to see if I made any changes. I did not. All right, now there's this funny little mark here. I didn't clear that off like I had planned to. What we want to do is we want to find the measure of arc KJ. This should be the measure of arc KJ, and it didn't copy correctly. All right, what we have is angle KHJ is equal to 20 degrees. So we're going to be working backwards here. Arc KJ is 4x degrees. All right, now what you got to keep in mind when you have two tangents, that it cut this arc in two. Not in half, but in two parts. So together they add up to 360. So if this is 4x, I would subtract that from 360 to get the other arc, because together they add up. So if I know one of them, subtract from 360. So arc KXJ is equal to 360 minus 4x. Now, the rule states to subtract the two arcs and divide by 2 and set it equal to the angle. Since I know my angle is 20, my bigger arc is 360 minus 4x. My smaller arc is 4x, so I'm going to subtract it from my bigger arc and then divide it by 2. All right, what I want to do is get rid of this denominator, so I'm going to do cross products. I'm going to multiply across, so that would be 40 is equal to 360, and since these are like terms, I'm going to combine them, minus 8x. All right, now I'm going to subtract 360 from both sides. When I do, I'm going to get a negative answer, and that's okay because my coefficient of x is negative as well. So I have a negative 320 equals a negative 8x. When I divide negative 320 by negative 8x, I get the answer of 40. So in this situation, if I'm solving for x, x equals 40. Okay, you will see problems like this. That's why I wanted to be sure and do one on the note example page. All right, so to go back through, just to recap, angle is half the arc. The angle is half the sum of the two arcs. That's when it's inside. And down here, when they're outside, it's half the difference. Subtract, subtract, subtract. And that's it.